In North America in 1991, Nintendo released a gaming console called the Super Nintendo Entertainment System, or SNES for short. This was their next leap into the world of gaming. Using a 16-bit microprocessor, this new system was going to create a new era into gaming. Yet, what is an SNES, and how does it work? The Super NES used three unique processors: the CPU, the Picture Processing Unit, or PPU, and the Audio Processing Unit. I should also be discussing the controllers and how they worked with the system itself. Also, I'll be discussing about the unique chips and cartridges that enhance gameplay. So let's dive into the heart of the console with the CPU. The CPU is Nintendo's own custom-made chip called the Rico 5A22, which is based on an Apple IIGS computer. It employs a variable bus that has three speeds: one for controlling the display processing, or WRAM, window RAM; another for controlling the video audio address bus, or the DMA, the direct memory access; and the last one controls the perspective of the screen, also known as the horizontal direct memory access, which actually worked with Mode 7, which I will discuss in a bit. Now, while the CPU handles all the inputs, there needs to be something that handles video, and thus the PPU. The PPU contains SRAM, Static Random Access Memory, which contains three registers: the VRAM for tiles and tile maps, the OAM for storing sprite properties, and the CGRAM for palette data. These three registers were instrumental in allowing the SNES to create amazingly lush colors, effects, and allowing for changes to be made during gameplay. Now, one of the finer things about the PPU is that it could run different modes that would work with background layers and would have certain color palettes to choose from. The SNES had 8 modes, and modes 0 through 6 are more commonly used for parallax, but mode 7 was unique and star of the bunch. Mode 7 took up 32 kilobytes of the 64 kilobyte VRAM and could allow perspective in-game. Backgrounds could now have a sense of distance, making and also could make non-sprites expand and shrink. Now, an example of this is the boss Cornot from Super Castlevania 4, where the boss was actually a background, and so it could turn and scale. Now, last we come to the Audio Processing Unit, or the SMP. A processor so remarkable that many of its many songs created by this unit are loved and treasured today. This little guy has its own CPU, known as the SPC 700, a DSP, a digital signal processor, an SRAM, and a boot ROM, which loaded information from the cartridge into the SPC 700. While sounds was still limited by times and hardware, many great composers pushed the limit of what this could do. Castlevania Dracula X is a game that is nearly CD quality audio and shows how much potential the SSMP actually had. Now, what is a gaming console without controllers? And there are many controllers to talk about. So let's start with the standard gamepad, which has 6 buttons. Now, this used 16-bit data, and 12 bits are actually corresponding to each input of the buttons, start and select, and the down pad. Now down and up could not be active at the same time, as the code in games cannot comprehend the command that would cause them, and it would crash. Same goes for left and right. Now the Super Scope uses an 8 bits, and 6 of them are for various functions, such as firing, off screen, cursor, turbo, pause, and noise. The sensor for the Super Scope that was on your TV would read the data from the gun. If it caught a target sprite on the screen after pressing the fire button, it would then change the value sent from 0 to 1 and send it to the receiver in the sensor. Funny enough, the Super Scope could not sense red, so many of the sprites had to be green or blue. Now the SNES also had a mouse that was very much like a trackball computer mouse. It used 32 bits, and 16 bits were for the function of the mouse, such as the buttons, and the others kept track of the movement of the mouse. Now cartridges for the SNES were often formatted with different chips to enhance gameplay and store data by the use of battery backup. Many of these chips included their own processors, such as the SA1, which increased its clock speed and RAM, and also compression to a degree only seen in very few titles, such as Super Mario RPG and Kirby Superstar. Another chip that was unique was the Super FX chip, which allowed 3D polygons. Now this would later be reworked into the Super FX2 chip that was used in Yoshi's Island for sprite deformation to smooth out the changes in sprites and make them look more natural. The CX4 chip used in Mega Man X2 and 3 allowed wireframes to be presented in the game. Let's see. While this video is brief on the SNES, I hope you still enjoyed it. I do think you should do some research of your own, as there are many things I still haven't really discussed about the Super Nintendo. It is a wonderful machine, and I hope you will look at some of the information I will provide down below in the links in the description. Anyways, you have a nice day.